Hey, this time we're going to be working on simplifying exponents. So what you should already know are the three exponent rules. If you already know those, you should be able to solve any of these. But yeah, so first up, we have all of this to the power of 2. We can notice that we have an x to the power of 0 in there. We know that anything to the power of 0 is 1. This is kind of a rule that you have to memorize. But yeah, once again, anything to the power of 0 is 1. So this tells us that inside the bracket, we have 3 times 1, which is just 3. And now, this tells us that we have 3 squared, because there's a squared here. And now this is equal to 9. 3 times 3 is 9. And that's kind of it for the first one. Once again, you kind of have to memorize this rule. There's no other way around it. But yeah, so if you know that, you should be able to solve this question, because it's pretty simple. Next, we have 3x squared to the power of 0. This exact same rule applies here. Since we have this to the power of 0, no matter what it is, anything to the power of 0 is equal to 1. Next question, we have 5xy over 15x squared y. So first, let's kind of put our focus into the numbers. We have a 5 and a 15. They are both divisible by 5. So this becomes a 1. And this becomes a 3. That's kind of pretty simple. That's the easiest step in this question so far. So we have xy over 3x squared y. Now let's put our attention onto the x's and the y's. So first, we know that if you only consider the x's, we have x over x squared. This is the exact same as x to the power of 1 minus 2. Once again, this is the quotient rule for exponents. And then this will give us x to the power of negative 1. And this is another rule that we know, but anything to a negative exponent is actually going to be 1 over whatever that thing is without the negative. So for example, I'm going to write it up here. If we have x to the power of negative y, this is the exact same as 1 over x to the y. No matter what number we have in the exponent, it's going to be positive in the denominator of a fraction. That's it. So what this tells us now is that x to the power of negative 1 is going to be 1 over x to the power of 1, or just 1 over x, because that's the simplest we can get to. So yeah, 1 over x. And now for the y's, we have y over y. Any number divided by any number is 1, but another way of explaining this is that we can use the quotient rule again. So this would be y to the power of 1 minus 1, which is equal to y to the power of 0, which is once again 1, because anything to the power of 0 is 1. But yeah, so now our final answer to all this should be the x's simplified to 1 over x, and the y's go away. So we would have 1 over 3x, and we're done. Because the 3 stays there, once again, the x's are simplified to 1 on the bottom, and then the y's go away. So that's it, we are done. Okay, question number 4. This one is a tiny bit more complex, but it's the exact same steps. So 18 and 27 are both divisible by 9. So the 18 becomes a 2, 27 becomes a 3. And then the x's, we can do it on the spot now. Let's try to be a bit faster. But yeah, so 2 over 3 stays. And then x, 1 on top, divided by x to the power of 4 is x to the power of negative 3. So we have x cubed on the bottom. And then we have, for the y's, we have y squared divided by y to the power of 4. This is y to the power of negative 2. So once again, that's 2 y's on the bottom, y squared. And then nothing simplifies with the z, so it stays on top. We can't really do anything with it, so we put it on top and we are done. This is the final answer. Once again, pretty simple, just simplify stuff until you can't do anything else. Yeah, question number 5. This one is a tiny bit harder, but same steps once again. First, let's do the brackets. We can notice that this is an exponent to an exponent. So what we can do first is write this out in another way. We can write this as x to the negative 2 all cubed times y squared all cubed. Basically, all I did was I put the 3 to the y's and the 3 to the x's. And then all this is once again over x to the power of 4, y to the negative 2. Now what we can do is do the exponent to the exponent rule. We can multiply these out. Once again, I'm assuming you already know this, but this would be x to to the power of negative 6, because negative 2 times 3 is negative 6. And then y is going to have a 6, because 2 times 3 is a 6. So we're done the numerator. The denominator stays the same. I'm just copy-pasting it from the previous step. And now what we can do is start subtracting exponents. We have x to the negative 6 divided by x to the 4. This is going to be x to the power of negative 6 minus 4, which is just x to the power of negative 10. This also works with negative numbers, by the way. This does not matter if it had a negative 6 or a 6. It works because it's a rule. It works no matter what. But yeah, so we have x to the power of negative 10, which is equal to 1 over x to the power of 10. And then for the y's, we have a very similar situation. But yeah, so we have y to the 6 divided by y to the power of negative 2, which is just y to the power of 6 minus negative 2, which is y to the 8. So yeah, all of this at the very end simplifies to y8 over x10. And we are done. So now we have our last 5 questions. Once again, here we have an exponent to a bracket. So what we have to do is expand this exponent of 2 to every number inside the bracket, every number and every variable. So we have the z, the y, the x, and the 4. But yeah, after that, it gets pretty simple. But I'm just going to rewrite the numerator as it is. So 8x cubed y squared z. And then the bottom is going to be 4 squared x squared y to the power of 2 all squared, and then z squared. Now this is going to be, once again, let me just copy paste the numerator. So 8x cubed y squared z, and then 4 squared is 16, x squared is x squared, we can't really do anything to that. Y squared to the power of 2 is y to the power of 4, and then z squared. Now we can start simplifying a bit. So the 8 and the 16 can both be divided by 8. So 8 becomes a 1, 16 becomes a 2. And then we have x cubed on the top and x squared on the bottom. So I'm going to write it up here, but x cubed over x squared is x to the power of 3 minus 2, which is x to the power of 1, or just x. So we have, so far we have x, 2 on the bottom. And now for the y's, I'm going to write it here again. So we have y to the power of 2 over y to the power of 4. This is y to the power of 2 minus 4, which is y to the power of negative 2, which is 1 over y squared. So we have a y squared on the bottom. And then for the z's, I'm going to write it a bit up here. So z over z squared. This is z to the power of 1 minus 2, which is z to the power of negative 1, which is 1 over z. And we're done. So we're going to have a z on the bottom. And this should be our final answer. So a quick summary of what I did. First, I expanded to get this part. And then I used the rule that we already know to get this. So y squared to the power of 2. I got y to the power of 4. And then after that, I basically started simplifying each number and variable together. So 8 and 16 were divisible together. X cubed over x squared, I did this to get x. And then y squared over y to the power of 4, I did this to get y 1 over y squared. And then z over z squared is 1 over z. I did that. But yeah, other than that, that's pretty simple. There's nothing else to it. But yeah, question number 7 now. Let's kind of do what we did the last time. First, we notice that the 13 and 12 cannot be divided by anything because 13 is a prime number. So we can't really do anything to that. Let's just copy paste it over here. 13 over 12. Now for the x's, I'm going to write it over here. So x to the power of 8 over x to the power of negative 7. This is x to the power of 8 minus negative 7, which is equal to x to the power of 8 plus 7, which is equal to x to the power of 15. Once again, you should probably already know this, but 2 negatives make a positive. And then, so yeah, we have x to the power of 15 on top. And now for the y's, we have y over 7, y to the power of 7 over y to the power of 2. This is y to the power of 7 minus 2, which is equal to y to the power of 5. So we have y to the power of 5 on top. And now for the z's, we have z over z squared, which is equal to z to the power of 1 minus 2, which is z to the power of negative 1, or just 1 over z. So we have a z on the bottom. And then for the k's, our last variable, we have k squared over k to the power of negative 4. This is k to the power of 2 minus negative 4, which is equal to k to the power of 2 plus 4, which is k to the power of 6. So we have k to the 6 on top, and we got our answer. So yeah, it might seem like it's pretty simple, which it is, but you have to focus that you're not adding or subtracting the wrong numbers, because a very common mistake is messing up on the double negative sign over here. So you have to be careful for that. But yeah, next question, we have x to the power of 7, y to the power of negative 3, and z to the power of 12, all multiplied by 6, over 3x to the power of negative 2, y to the power of negative 4, z to the power of negative 6. So first, let's do what we do every time. The 6 and the 3 can be divided by 3. So the 3 becomes a 1, the x becomes a 2. So far we have 2 on top. And then for the x's, we have x to the power of 7 over x to the power of negative 2. This becomes x to the power of 7 minus negative 2. And then this is x to the power of 7 plus 2, which is x to the power of 9. So we have x to the power of 9 on top. And then for the y's, pretty similar once again. We have y to the power of negative 3 over y to the power of negative 4. This is y to the power of negative 3 minus negative 4, which is equal to y to the power of negative 3 plus 4, which is y to the power of 1. So we have 1y on top. And then for the z's, we have z to the power of 12 over z to the power of negative 6. So this is pretty simple again. This would be z to the power of 12 minus negative 6, which is equal to z to the power of 18, which is equal to that over here on top. So I can actually get rid of this line over here, because this is not a fraction anymore. It's almost like a whole number with fractions not existent. So yeah, that's it for this answer, and we are done. Our two last questions, so let's do the exact same thing for these two. First, let me write the line for the fraction. Over here, there's nothing to cancel with the 2, so I'll just copy paste it over here. There's nothing to cancel out with it. For the x's, we have x cubed over x squared, which is equal to x to the power of 3 minus 2, or x to the power of 1. So we have an x on top. For the y's, we have y to the power of negative 7 over y to the power of negative 10. This is equal to y to the power of negative 7 minus negative 10, which is equal to y to the power of negative 7 plus 10, which is equal to y to the power of 3. And we're done that, so y to the power of 3. And for the z, there's nothing to cancel out with it on the bottom, so we can just copy paste that to get z to the power of 12 on top, and we are done. Once again, pretty simple. And just to make it neater, I can finally rewrite this as x, y cubed, z to the power of 12, all over 2. Just to make it neater, but I just copy pasted it. So we're done. And then the final question, we have 14 and 7 again. So this time we can simplify both of these by 7. This becomes a 2, 7 becomes a 1. So far we have a 2 on top. And then for the x's, we have x to the power of 2 over x to the power of negative 3. So this is the exact same thing as every other time. We have x to the power of 2 minus negative 3, which is equal to x to the power of 2 plus 3, which is x to the power of 5. I can write that down now. And then for the y's, we have y to the power of 3 over y to the power of negative 6. This becomes y to the power of 3 minus negative 6, which is equal to y to the power of 3 plus 6, which is y to the power of 9. So I can write that on top. And then for the z's or z's, once again, there's nothing on the bottom, so we can just copy paste it to be over here. So z to the power of 12. And for this question, once again, there's nothing on the bottom, so I can erase the white line and put this on the bottom, so that now we know this is our final answer, and we are done.